Hi, are you planning to start a new project with frameworks like AutoGen or Semantic Kernel from Microsoft? Or have you already started one? Please stop and watch this video first. Why do I say it? Because Microsoft Agent Framework is there, which is relatively a newer framework than Semantic Kernel or AutoGen. And the intention so far, it looks like Microsoft wants that the users shift to Microsoft Agent Framework. So if we have a look at the numbers, AutoGen is quite popular framework already. Significant number of forks and starts already you can see on GitHub. And similar is the case with Semantic Kernel as well. But if I have a look at Agent Framework from Microsoft, this is relatively new. And when I went back into the commit history, I found that the first commits were in June 2025 only. So yes, this is relatively new. And why I say that Microsoft want or willing users to move to this new framework is that documentation already having quite descriptive sections for migrating AutoGen based and Semantic Kernel based applications to this new Microsoft Agent Framework. So in this video, we will try to find out which problems Agent Framework, the new Microsoft Agent Framework, claims to solve. If you have a look into the documentation on the homepage of this Microsoft Agent Framework, Microsoft claims that they have taken out the best parts out of these two very popular frameworks to build this new framework. So what are those? I have created some key points out of this documentation so that we can summarize it very quickly. So Semantic Kernel was having some challenges like while creating multi-agent coordination. Semantic Kernel was a single agent focused framework. So what MAF or Microsoft Agent Framework brings us as a solution is it creates a graph-based workflow with multi-agent patterns. So when I say graph-based, it doesn't mean that it is having something like Flowwise or Langflow or tools like that where you can drag and drop and connect. No. It is pretty much speaking about the logical graph that you can create while coding. We will see the code samples, how we can create the graph-based workflow in a moment. Another challenge this Semantic Kernel was facing was dynamic agent conversation. It was pretty much deterministic only. And how MAF solved is hybrid model supporting both deterministic and dynamic. So how multiple agents speak to each other. They can be autonomous and you never need to fix a conversation. Then there was explicit control like things. It was not so flexible. So workflow was not at all there. In the Semantic Kernel, it was a single agent focused system. So in MAF, as I already said, there is native graph workflow with conditional routing as well. How multiple agents speak to them. There are lots of supports in the API itself. For example, on the basis of a response of an agent, you can decide in the logic, in the business logic of your code, who will be the next speaker like thing. And you can already do this in various other frameworks, for example, in AutoGen itself. But this is very, very cleanly implemented this time. I will show you the example. Now, if we speak about the AutoGen was lacking its production readiness. It was pretty much research focused, used for experimentation. Yes, this AutoGen was made for multi-agent AI applications development, but how MAF solves this production readiness point specifically. So in MAF or Microsoft Agent Framework, I will be interchangeably using those terms, Microsoft Agent Framework or MAF. So in MAF, you have built-in telemetry, lots of tracing and logging, and some security, and you can do filtering for the safety purposes so that you do not leak the private information or sensitive information. And you have lots of middleware. Some of them, again, we will see some code samples in a moment. Long running task. How do you maintain the state? Where is your particular or specific agent is? That was a challenge already in AutoGen. So there was no persistence mechanism for the long running tasks. So how do we do it, or how MAF solves it, is by implementing checkpoints and resumable workflows. This is one of the important feature that MAF brings in. You can create checkpoints, you can hold agent, and you can resume its working based on some input. For example, type safety. So dynamic and untyped the AutoGen was, but now with MAF you have a strong type system with validation. So I made some notes. This is not like data types, but we are speaking about here continuous schema checking for messages and tools between agents, so that message schema is same, uniform, it is checked. And similarly when you speak to tools, so the responses coming from the tools and the request you are making for the tool invocation. So MAF validates edges, agents and tools, and catches from form and type errors before runtime. So semantic kernel was doing it partially, and AutoGen was totally untyped in this specific case. Then the next challenge AutoGen was facing was state management. It was manual tracking. Here you have thread-based state management, like you have the states in the thread, but what additionally MAF has done, I have again made some more points for clarity. So MAF have threads which maintain multi-turn state and can be checkpointed. And MAF combines typed thread state with workflow checkpoints for pause, resume like things. So it is maintaining states of various agents or overall workflow management. Workflow is might have multiple agents being executing various tasks. So that state you can really manage using MAF, and there are very simple and handy APIs to do that as well. Human in the loop. So what if you want input from the human, for example, for the confirmation or for the operations which are quite sensitive, like deletion of a file, for example. So there is native request response pattern for pausing, waiting for release or waiting for input, and resuming with intact state or typing. So this support is already there in the native APIs of MAF. So if we summarize the core building blocks of MAF, there are AI agents, of course, and workflows. This is a new thing which they call it to be graph-based execution with modularity. So you will have the feeling of a graph while creating multiple agents. Multiple agents acts like node, then they have properties, then they have edges. What is the relation between two agents? So edges are used for that, and there are tools which you can attach to each agent. We will see the code sample. Then you have agent threads for the state management. Then you have context provided, for example, history or memory conversations. Middleware, of course, MCP client APIs as well. So that was in brief what Microsoft Agent Frameworks brings on the table. Basically, it takes the enterprise-like features out of semantic kernel, and it takes also the power of AutoGen when it comes to multi-agent conversation like things. So it's a nice combination of the powers of both these very popular frameworks already. And I must admit that while researching and preparing code samples, I was impressed what they have delivered. So let us jump into the code and try to see what agent framework has brought us. So not really everything I have covered in the codes, but majorly the 4 highlights of this MAF framework I have tried to cover it. For example, workflow, the observability like telemetry and tracing support, the security feature, and the integration with the tools, how it works. So let us open the workflow thing. So what I'm trying to do here is I'm using Grow client. By the way, this is again the wrapper around a class which is available in MAF, that is base chat client. By the name of it, you might already guess that I will be making some LLM requests using this chat client. So that's not so important, but the important thing to note is you have all the APIs already inside the agent frameworks. So you really need not to add a new dependency from Grok, for example. Let me minimize this thing. So this is a key from the Grok. Now here is the main part. I have this client that already created, but have a look at this. I have 4 agents prepared. I'm trying to mimic here a software development team. Agent 1 is a classifier, for example, which classifies the incoming request from the test team, for example, if it's a bug, a feature request, or just a question like thing. So this will classify, then this will further pass on this incoming task to a relevant agent, to a specific agent who can handle either bug, this is a bug handler, who can develop new features, feature handler, and a question handler. So you can already see there is a graph being created between various agents here. One agent acts like a main agent, and this main agent, which is in our case is classifier, it tries to transfer the task to various agents based on some condition. So how we bring all those together, the agents and the condition, and who is the initiator or the main agents here. So this is a workflow. You have the workflow builder class in the agent framework. You just instantiate it, and inside this workflow you just keep on registering your all 4 agents first of all. Then this is the edge, and this is actually telling you how you are going to associate each agent with each other. So you can already imagine we are trying to create a connection between between all of the agents. So here is the classifier. So this section of the code is explaining that how other rest of the 3 agents are connected to classifier based on some condition. And literally here we are implementing kind of switch case. It's a case 1. If there is a bug like pattern in the response coming out of classifier, then the task is given to bug handler. If there is a feature keyword coming in the response that is generated by classifier, then it goes to feature handler, and rest of the request goes to the question handler already. So this is how you create a workflow. And if you see further at bottom, it's a set start executor. This is a main executor where your initial user calls lands upon, and then you call a build method and your workflow is ready. Now you can run it and pass the incoming user requests. And how does classifier identifies that it's a bug, it's a feature, or it's a question like request? So it is written in their instructions already. Classify, is this a bug, feature request, or question? Reply only with bug, feature, or question in the response, for example. So if with the help of this LLM, it identifies whether the incoming query of a type bug, request, or question, and it just puts a single keyword, bug, feature, or questions, and then rest of the things are handled in the workflow here. So this is how easily you can actually create a workflow in MAF framework. And similarly, you can see the instructions for rest of the agents here. So once you have your workflow created here, to start it, you just need to call a single method, that is run. That's all you need to do. And what we are passing in our workflow are 3 user inputs, which we are mimicking. In a real world application, you might be having a chatbot where the inputs would be coming from user, for example. But here, for example, the login button crashes when clicked. So this you can already guess, it's a type of bug. Add dark mode to the app. This is a new feature. And what is the current version? So you can already guess. This is just a question, neither a feature nor a bug. So we will see if our workflow is able to identify as expected, identify the various cases as expected. So I will just go ahead and run it, and we will see the output, what's in there. So if I try to map the logs from the beginning, so this is feature 1, graph-based workflows we are trying to understand, and you see these logs. The provided chat client does not support function invoking. This might limit agent capabilities. These are actually coming from the framework. I haven't seen any right away flag or something where I can disable, but I'm sure there should be some mechanism to disable those logs. Now the important thing here is the created agents here. So this is the print. We have created classifier, bug handler, feature handler, and question handler. So these 4 agents has been created. Now we are building the graph workflow. So this workflow where we registered all the 4 agents, and also we have defined the edges, and finally we have built everything. And here is the log that is being printed. Built graph workflow with switch case routing. We have defined a routing using switch case, a conditional routing basically. Now we have a graph structure. So we have a classifier which will conditionally route the request to various other agents. So we have our workflow created, and here is the execution. We had 3 requests, and we were passing these 3 messages, user request, whatever you want to say, one by one, and here is the output. So the first request was the login button crashes when clicked. So this is a bug. Now again, no outgoing edges found for executor bug handler. This message again is coming from the framework, but this is highlighting a special property which we are discussing right now, the workflow, the graph-based workflow. What it is trying to say is, for classifier we have defined 3 edges. It has connection to these 3 agents, but bug handler here is kind of leaf node which doesn't have further connections. So that's what it is saying, no outgoing edges found for executor bug handler. So bug handler is kind of dead end. Once a request which is considered to be a bug, it lands upon bug handler, and now it's bug handler's responsibility to handle that. And if it cannot handle, it doesn't do anything else. It will just give the response. But in the real life scenarios, in more complicated systems, you might have multiple agents further acting on or further defined as an edge of bug handler. What if it cannot fix a bug? What if some error happens? So such things can happen, and you can design your complicated system out of these APIs as well. So let's get back to the question. Then the question was, the login button crashes when clicked. So no outgoing edges, that we have already discussed. Classifier said it's a bug, and that's why it was routed to this handler, this agent, that is bug handler. Now the response is login button crash. So the response was just that the report has been produced by this bug handler. That's all what this bug handler agent is programmed to do. Create a report, issue description, steps to reproduce, possible causes. So it was the job of the bug handler, and it has done its job. Now the second input was add dark mode to the top. Again the same message. This feature handler also doesn't have any outgoing edges, and classifier looked at this message and classified it to be a feature type and routed to feature handler. And now the feature handler agent produced this output. Similarly, the third request came in. What is the current version? It was of question type, and it was classified as question and was routed to this question handler, and this is the response of the question handler agent, which was very Short because it found like two-way, and this is a classical example where you want to bring more agents into the picture, where it can like route it back to the user. You can basically create a checkpoint and ask for user input. Two-way, current version of what? So that's pretty obvious. Any agent will ask for, if it doesn't have any context or memory or any kind of history being passed to. So yeah, this was an example of how you can implement the routing between agents, the conditional routing between agents, and how a workflow, a very basic workflow looks like. But there are lots of features which MAF supports actually. I have just mentioned them point wise. For example, there is a feature called fan out, where one executor sends messages to multiple executors. Executors, here we are referring to, for example, agents. The example would be, for example, in our specific case, classifier may send messages to all of them simultaneously. Then fan in kind of feature is there, where multiple executors send messages to one executor. For example, bug handler, feature handler are sending a message to an agent or executor called merger. Switch case routing, which we have already seen in this example. Then there can be parallel executions, the state management feature which we discussed, the thread-like state management. Then message passing between the agents can happen. Then there are lots of things you can do in regards to graph-based workflow. The next feature which we can discuss is observability. So in observability, we will notice that MAF automatically integrates open telemetry tracing with a real LLM calls. And how do we do it? By calling this single function. And you have all the open telemetry native tracing enabled. And you will start seeing a lots of metrics being generated related to your agents, how they are acting, what state they are in, and also related to your LLM calls as well. So how do we do it? As we said, by the calling of this single function. So we have imported this into our this Python module, and that's it. As soon as you call this function, you will see the metrics. There are a lots of parameters which you can override inside this function calling. When you call this function, I mean, but I am using just the default values of everything. So we can go with that, and you still will have a lots of metrics. We will see, we will try to run this code as well. So again, this is a Grow chat client. I will not discuss this in detail. And here what we are doing is, we are this time creating a single simple agent. Our intention here is to see what all observability, tracing or metrics are available, which are already natively the part of MAF. Just simply run this module and you will see this output. We are demonstrating the feature number 2 here, which is automatic open telemetry tracing with real LLM calls. By the way, in any other application, you can still get the support for open telemetry. There are Python packages for that, for the people who don't know that. But the beauty here is you need not to import the separate functions, classes, everything from open telemetry here. And you even need not to define the open telemetry as dependency on your project. Only this one single thing does everything for you. So let us get back to the output. We have created a single chat agent here. And what this chat agent does is like instructions. You are a helpful assistant. Thank you very much. And now we are starting the workflow, or it's a single agent. So just run the agent. And what we are asking our agent to do is, what is 2 plus 2? Most of the LLMs know how to respond, and what should be the answer. So agent response was 2 plus 2 equal to 4. LLM call completed, spans automatically captured. So we will have to understand this term span before I show you the output, the metrics, the tracing output. Span is a part of the activity tracing system. This is basically a unit of work in the workflow. It is influenced by the open telemetry concepts. So this is pretty much natively integrating the concepts of open telemetry as well. It represents a single step in an agent's execution pipeline. And in output, what you see now is this block. You basically see the two blocks here, one block and second block. The first JSON block is open telemetry log record. It's not an span yet. So what is span? It's a single step in agent's execution pipeline. So agent might be doing multiple things. So this is a single unit of a work. You can say it like that. But this first is the kind of metadata, or to be specific in output, the first block is an open telemetry log record. But the second one is the span metrics. The metrics about a task which agent was performing. For example, the name was invoke agent helper, context was this, what kind of this task was or span was, then start end time like metrics, and lots of other things which you can really use if it comes to the benchmarking of your application, if it comes to the cost reduction, for example, when it comes to token exchanges between LLM. So really enterprise grade solutions we are having in MAF already. The next feature which we are going to see is the security and safety related things. So in this Python module, I have shown a demonstration about the APIs which are related to security and safety. So the function approval mechanism is there, which we will see. Control which function agents can call with user approval. So for some things you really need a user approval. For example, in this specific case, what we are going to implement is a delete file operation, where we expect that agent asks for the user approval. And have a note on this decorator. So in MCP, if you have implemented the MCP server, there are @mcp.tool, mcp.prompt, and resources like decorators. Similarly, you can define the functions, or let us call them again tools. Delete file can be considered to be a tool, and by just this decorator, make this function visible and callable by AI agent. So if you put this decorator on the top of any function, now you can program your agent in MAF so that by just giving the name of the function and the inputs in form of some JSON, it can call this function automatically. So create an approval request with function called details. So this is a class function approval request content, and there are multiple IDs which are very important to be defined in a unique way, so that if, for example, a state being maintained, there is a pause, there is a checkpoint has been created, and you are expecting a user to give an input. So the input will be coming by mentioning the same IDs, and then you can basically connect on which thread, on which state my thread was waiting, and now I have the approval, or I have a go ahead from the user, and I shall proceed this specific thread further. So there is a function ID, unique request ID for tracking, function call content, which function you are going to call, for which the approval is expected, again the call ID, the function name, and the argument in form of JSON. Delete file was the function, and file path is this thing. For this, for example, I have hard coded it, but that won't be the case in real life scenario. And this is a function approval request created. Now function approval response content, it is a response that is coming from the user. So that will be programmatically wired with a chatbot. What I'm showing you is the core idea in the framework that is available. So this would be the response content that would be created out of the user input. So for this, for example, if this is the approval request, that will be going on the chatbot, for example, in any of the chatbot, and their user might say, go ahead or don't delete it, such responses, there would be some LLM involved which will translate the user input that user don't want to approve this request. So in that case, it would be like approved equal to false. So in between, there might be happening some LLM message exchanges, LLM request, which actually translates either the user have approved it or not. And then at the end, whatever agents are involved in this span, the unit of a task by an agent, and then they can open those variables to know whether it was approved or not. Let us try to run it quickly. MAF feature number 3, security and safety for function approval, sensitive function defined, which we already did. Agent want to call delete file, and approval request was created and user decision was denied. So the false was translated in a denial of the execution of this sensitive function. So this is how you can basically define the approval request and create the response out of a user input. For example, it might be user input, or it might be the output of another agent, which might be a kind of auditor, for example, in your system. It totally depends what kind of AI system you are building. So again, in security and safety, I just demonstrated a kind of approval request and response scenario. There are lots of security and safety related features again in MAF. I have listed a few of them. For example, functional approval, content filtering, for example, filter harmful and inappropriate content from agent responses. You can define guardrails, rate limits, prompt injection, PII, lots of things are there. Just a pointers which I have kept here. The another feature which I want to show you quickly is the tools, how it integrates with the tools. So in this, agent calls Python function automatically, which we have already seen, the AI function decorator, very simple, handy to call. And the key is define tool with this decorator and everything gets done for you. A very simple thing. I have defined two tools. If you have developed MCP servers, you might be already familiar with such decorators, just that in this case, these decorators are already available in MAF as well. So again, we have defined a Grok chat client here. I will skip this part. Now this chat client, here it is, and we are creating an agent, the chat agent. It has got the chat client, the LLM client basically with Grok, and we have registered these two tools. Now what will happen? The user query will come in, and there are two tools. The LLM will automatically decide whether the call, the input user has given is related to getting a weather forecast or current weather, for example, or it is related to some calculation, mathematical calculation. To give you an example, you can see we have started the agent and we have passed this input here. What is 25 times 4? So when it lands on the agent has got this LLM support, and the chat client automatically decides, okay, this is something mathematical calculation I'll have to do. So it will automatically call this calculate tool which we have defined. And you even need not to prepare the input, the arguments which you need to pass in any form of JSON or something. You just pass in the tool, register the tool, everything will get done for you. Let me run it for you. So here are two tools which we have defined in our Python module. The provided chat client does not support function invoking. That's again a log message coming from the MAF framework itself. Then we created chat agent with two tools here. This is the log which is being printed. And testing agent with the query. Now we are passing this query, and agent right away responded the answer. You need not to create any JSON formatted argument or anything. You just pass in and tools are there. Everything will be decided by the chat agent. So it was a quick overview about this MAF, Microsoft Agent Framework, which clearly is relatively new to semantic kernel and AutoGen like frameworks, which are nicely established already in the market. Now it will be interesting to see how people react to this new framework. I'm pretty sure there are applications which has been developed over the time using these quite nice frameworks, AutoGen and Semantic Kernels. Now we have this enterprise grade, according to Microsoft, enterprise grade framework already in the market. But certainly if you are planning to develop a new project, or you have just started with a new project, a multi-agent system, this MAF is worth checking. I hope you like the video. Thank you for watching.